Okay, so let's solve this problem. So prove that this given is an identity, and these are the different steps in proving identity. So first, we need to work on the complicated side. Now, since on this given, this is more complicated side, so we're going to work on that side. Then change all the functions to sine and cosine. So for tangent, that's sine over cosine. For cotangent, it's cosine over sine. For secant, that's 1 over cosine, and this cosecant, it's 1 over sine. Then do the given mathematical operation. So again, since we're going to work on this side to make it equal to tangent squared x, so we're going to change everything to sine and cosine. So we have this cosecant squared. Now, since cosecant is equal to 1 over sine, but since cosecant is squared, so therefore this one is 1 over sine squared x times this tangent, that's equal to sine over cosine, but since tangent is squared, so this becomes sine squared x over this cosine squared x. Then bring down this minus 1. Then simplify so we can cancel the sine squared x. So we have now 1 over this cosine squared x minus 1. Then we have this figure to identify the different fundamental identities. So this is 1, this is cosine, this is secant. Now for secant, that's 1 over cosine, and we have this 1 over cosine, but cosine is squared, so therefore this function is equal to secant squared x from this fundamental identity. Then you bring down minus 1. Then we also have this identity that tangent squared plus 1 is equal to secant squared. Then if we're going to transpose this one to the right, so we have now tangent squared is equal to secant squared minus 1. And that's secant squared minus 1, secant squared minus 1, that's equal to tangent squared. So therefore, this equation is equal to tangent squared x. So we have now equal equation.